Derivatives of trig functions. Let's remind ourselves what the graph of y equals sine x and y equals cos x looks like. So this is y equals sine x, where we start at 0, 0, and we go up and down and we have one full period at 2 pi. And then y equals cos x starts at the 1, and we go down and then up, and we have one full period at 2 pi also. So let's take the derivative. So we're going to think of the derivative as the slope of the tangent to the curve, and we're going to draw the derivative of each function. So the first thing that I know is that whenever I change directions, that will be an intercept in the derivative. So that means that I'm going to get these two intercepts right here, and this intercept right here. I also know that from in between these 2 points, that the slope is decreasing. So the derivative function is going to have the values that are negative. Then the function is increasing in the next portion. So the derivative function is going to have positive values. And this is the same here. I have an intercept here. The graph is increasing. And so I have positive values for my function. And let's do that for the cos function too. So my critical numbers are where I change directions, and those become my intercepts. The graph is decreasing at this point in time, so the derivative is negative. The graph is increasing, so the derivative is positive. And what you should see is that the derivative of the sine function actually looks a lot like the cos function. And the derivative of the cos function looks a lot like the sine function, but just upside down. So we can record this and we can say if the function is the sine function, then the derivative of that function is actually just the cos function. And then the second case, if the function is the cos function, the derivative of the cos function is actually the sine function, but inverted. Okay, so when we're taking the derivative of a trig function, we have to remember to use the chain rule and treat the argument, so whatever is inside the trig function, as the function, as another function. Okay, so we're going to take the derivative of y equals sine 2x. So my first step will be to take the derivative of sine, and the derivative of sine is cos. So the derivative will be cos 2x. But then I also need to take the derivative of the argument. And the argument is 2x, and the derivative of 2x is 2. So the derivative of sine 2x is 2 cos 2x. Okay, let's try some more examples. All right, we're going to take the derivative of sine with the argument x squared minus 3x. So derivative of sine is cos. This stays. And then I take the derivative of the argument. I'm going to rearrange that just to put it in an order that we normally see. Not a necessary step, but good practice. There and done. Okay, now I have two functions. I have this function and I have another function. So I'm going to use the chain rule. So take the derivative of the first. Keep the second. plus, keep the first, take the derivative of the second, and also the derivative of the argument. Now I'm going to clean this up. Oh, sorry, I should have a negative sign there because I got a negative there. This 2 and this 2 will cancel. Okay. I'm also going to look to see if I can use any trig rules or factoring to clean that answer up further. I can't in this case. All right, now I have a power function here, so I'm going to use the power rule. Bring my exponent down, reduce my exponent, and write it again. And then I'm going to take the derivative of what I just had. So the derivative of sine is cos. And then I need to take the derivative of the argument, which is just 4. Okay, I'm going to clean this all up. I'm going to put the 3 and the 4 together to give me 12. Sine squared 4x. And then cos 4x. Okay. Power rule and more. Okay, so I'm going to bring this exponent down. Keep what it was. Reduce the exponent by 1. And then take the derivative of the inside. So the derivative of this first thing is negative sine x squared. And the derivative of x squared is 2x. The derivative of the second part is, the derivative of sine is cos 2x, and the derivative of 2x is 2. Now I'm going to clean this up. I have a negative 2 here that I could factor out if I wanted. I probably should do that. So I'm going to bring that up to here. Oh. And I've got an x there too. I'm going to include that, this 2x. And, oh shoot, I can't actually do that. I don't have an x over here. One more small step. I can combine these two to give me negative 4 cos x squared minus sine 2x and x sine x squared plus cos 2x. Okay, let's try a trickier one. All right. First up, I'm going to take the derivative of the top. Derivative of sine is cos x. Then I'm going to leave the bottom as it is. I'm going to subtract. I'm going to keep the top and take the derivative of negative cos 2x. So the derivative of negative cos is negative sine, and the derivative of 2x is 2. That's all divided by the bottom squared. Okay, I'm going to clean this up a little bit. So I've got cos x, 1 minus cos 2x, minus 2 sine 2x, 1 plus sine x, all over 1 minus cos 2x squared. And one more. Here we have implicit differentiation. So first step, I'm going to take the derivative of this. Derivative of sine is cos. And the derivative of y, I don't know what it is, so I'm just going to write dy dx. Derivative of cos is negative sine x squared, and derivative of x squared is 2x. I want my final answer to be the derivative of y in regards to x. So I rearrange for that. Okay, a bunch of homework for you to practice. Page 313, numbers 1 through 3 and 7.